All right, I just wanted to make a quick video going over the Topic 7 review. It's already done, so I'm not going to do it on camera, but I kind of want to talk about a few problems that are common missed problems, including number 7. So number 7 has K as its center of dilation, and that's what throws a lot of people off, because what we're trying to find is we're trying to make all these points 3 times further away from K, which means K prime will be the same as K, because we're not moving that one any further away from itself. But when we look at L, what we can do is we say, well, the x-coordinate of K is 0, the x-coordinate of L is 3. The x-coordinate of L prime needs to be 3 times further away from 0 than the number 3. So 3 times 3 is 9, so we would do 0 plus 9 to get 9. For the y-coordinate, same deal. 4 to 0 is a negative 4 change. We need 3 times that change, so negative 4 times 3 is negative 12. So then we take 4 and do 4 minus 12 and get negative 8. M prime, same thing. From K to M, the x-coordinate subtracts 2. We're going to take that negative 2 and multiply it by 3, which is negative 6. So 0 minus 6 is negative 6. 4 to 4 is 0 change. And so if we do 3 times 0, that's still 0 change. So from 4, we're going to make 0 change, and M prime's y-coordinate will still be 4. In number 8, the first thing we need to do is make a dilation by a scale factor of 1/3 to shrink this red shape down towards the origin. And then we need to do a reflection over the line y equals negative, that should say y equals negative 1/2, because that's going to flip that little shape down on top of wxyz. We cannot do them in the other order this time, because making sure that our shape grows or shrinks towards the origin is going to happen first with that dilation. Once we reflect it, it's going to be somewhere else on the page. Number 9, we've got to see whether this is a similarity transformation, but she said going from ABC to PQR is a scale factor of 2, when really we're going from the big shape to the small shape, so it's a scale factor of 1/2. Number 10, we can make note that we have congruent right angles right here in the middle, and then the side lengths that are attached to those right angles would be 9 and 6 for the medium-sized triangle, and 6 and 4 for the small triangle. And since 9 over 6 equals 6 over 4, those are proportional. And because they have a right angle right here, they're proportional by side angle side similarity. Number 11, we have 3 congruent proportions, 3 equal proportions, when we divide and make the ratio of 2 over 4, 3 over 6, and 4 over 8. So those triangles are similar by side, side, side. For this one, if we wanted to use angle-angle similarity, we just need to figure out how to find 2 angles of this triangle. And we can do that a few different ways. We can say, well, if this one's 78, if we knew another one, we would be able to do 180 minus 78 minus this angle to find this one. And that would give us these 2 angles, x and y, being corresponding to these 2 angles, t and v. And if they're the same angle, then those triangles are similar by angle-angle similarity. Numbers 13 through 15, I used altitude on hypotenuse theorems. So to find RS, I said, well, that is a leg of the big triangle. And the leg squared is equal to the piece of the hypotenuse closest to the leg times the entire hypotenuse. So x squared equals 4 times 16. And then we solve that and we get x equals 8. Same thing for ST, the leg squared is equal to the piece of hypotenuse closest to that leg multiplied by the entire hypotenuse. So y squared equals 12 times 16. You solve for that, we get y equals 13.86. And finally, SU, the altitude squared, equals RU times UT, equals the 2 pieces of the hypotenuse multiplied together. And so z squared, I called it z, equals 4 times 12. Take the square root, and you get z equals 6.93. For number 12, when we're using the side splitter theorem, we can divide this triangle a number of different ways, but we know that the sides will be in proportion with one another. So I can say 32 over x equals 20 over 30 and solve that proportion. For 17, same thing. Even though it's not a triangle, I can use the side splitter theorem because I have parallel lines here. So I know that 18 over this other piece x is equal to 20 over this other piece 16. Number 18, I'm going to use the triangle angle bisector theorem. Make sure you don't try to use altitude on hypotenuse theorems here. This is not an altitude on hypotenuse. This is an angle bisector. There's no right angle in there at all. So I'm going to use the angle bisector theorem, 8 over x equals 5 over 2.5, and then solve from there. Number 19 is a little bit tricky because we have to remember sort of a little math strategy that we can use if we are missing a variable or a value here, which is that if we know the entire length of a two-part segment, one of those segments can be an unknown x, and the other one can be the entire length minus x. So this is 5 minus x. Then we can make a angle bisector proportion with 9 over x equals 6 over 5 minus x, and we solve from there, and we find that x is equal to 3. Number 20, if we have this right triangle and the altitude is jk, then what is gj the geometric mean of? So gj is a leg of the triangle, and we can think about this in two different ways. We can think about gj as being part of a proportion where gj is the top number in the first fraction and the bottom number in the second fraction. And when we do that, we find that that would be gj over gk, so that's hypotenuse over medium length side of the medium triangle, is equal to gh over gj, hypotenuse over medium side of the large triangle. Another way to think of geometric mean is to say, well, the geometric mean is the square root of the product of two numbers. So if we multiply gk times gh, the piece of the hypotenuse closest to gj, multiplied by the whole hypotenuse, and take the square root, we get gj. Number 21, what two smaller triangles are similar to triangle ABC? What I do here is I kind of trace ABC to figure out the order of the points. So if I trace through, that goes medium side, short side, hypotenuse. So I'm going to take this middle-sized triangle and trace it the same way. Medium side, short side, hypotenuse goes A, D, B. Small triangle, same thing. Medium side, short side, hypotenuse, B, D, C. So now I know that those vertices are in corresponding order. Number 22 is a fun quadratic. If we want to find the values here, we're going to be able to find the value of x first. We know the leg of this triangle, this right triangle. So the leg squared is equal to the piece of the hypotenuse closest multiplied by the entire hypotenuse. 65 squared is equal to x times x plus 144. And then we're going to multiply through. We've got a quadratic here. We're going to set it equal to 0 by subtracting 4,225. Then I'm looking for two numbers that multiply to negative 4,225 and add to positive 144. There's not really a shortcut for finding those numbers. You just got to divide and find those factors. We get x plus 169, x minus 25. And since we're using the zero product property to find our factors, we would say, well, that means x is equal to the opposite, negative 169, x equals 25. And since x is a piece of the triangle, it needs to be a positive number. So x is 25. Once I find 25 here, I can find the altitude because I know that the altitude is equal to the small piece times the longer piece of the hypotenuse. So h squared equals 25 times 144. Solve that, and we get h equals 60. And then finally, finding 23 through 25 using the side splitter theorem. I can do this a number of different ways, but to find x, that is the base of what I would call the medium triangle in these three triangles. We have a small, medium, and large. So what I can do is take the left side, which I know all of the medium side, over the base. So 6 over x equals the left side of the whole big triangle, which is 12, over the base, which is 13, and solve that proportion. To find y, I can do a pieces and parts thing with the side splitter theorem, where I said 4 over 2 is equal to 6 over y, because I can take pieces of the sides and compare them. And then to find z, I needed to take the left side, which was 4, over that base, which was z, over the entire left side, which is 12, over the base, which is 13, and solve that proportion. And that's going to give me z equals 4.3. So I hope this helps you go over some of the trickier questions on here. If you've got any questions, make sure you let me know, and have an awesome day.